And I'm going to go back to Hal.
Well, good morning to everyone today, and a happy Apollo 11 celebration for each and every one of us around the world that's participating. Goodness, I've been speaking quite frequently in the last couple of 3 weeks coming up to this time of the 50th anniversary. I was at the Smithsonian Air Museum last weekend, speaking there to the young people there that they had gathered in an audience at the Air and Space Museum in Washington, D.C. So we've been just being part of a kickoff, you might call it, of the celebration. My involvement in Apollo 11 began in early 1968 as a part of the CORAD Laser Division, where I was an employee. That company was headed by Dr. Ted Mayman, the inventor of the laser. However, I'd like to now just bounce back for a moment to my career. I started out in aerospace in 1955, even before they called it aerospace, of course, as many of us know. But I began working with Douglas Aircraft Company, and then moved on to my engineering courses through college, and then became a member of the technical team that built the first ballistic missile early warning system for the nation in the Alaskan frontiers in 1959. Subsequent to that, then followed that with work with Space Technology Laboratories, which eventually became TRW, if we remember those names, where we built the first relay satellite, which was the first communication satellite in history. From there, I moved on to the laser industry at CORAD and Union Carbide Corporation, and then concluded my engineering endeavors with Hughes Aircraft Company, working in the laser electro-opticals division, primarily in military laser applications. Going back to Apollo 11 again, and you see on the screen, we're looking now at the laser lunar reflector there. Joe, I think you're going to leave it there for a moment? Okay. Yeah, the lunar laser reflector there was the object of our mission on Apollo 11. I was responsible for operating the most powerful laser at that time in the world from Lick Observatory just here outside of San Francisco in the mountains here. San Jose. Near San Jose, yes. And one of the objectives of this particular mission was to locate the reflector. It would be, of course, as we would imagine, a task that was quite difficult because, again, even though we knew where the landing was supposed to take place, as we all recollect, Neil Armstrong did maneuver the lander at the last moments to avoid a crash with boulders in a large crater, which took him outside of the program landing zone we had characterized for nearly 6 weeks. With that as a problem, we then were forced to search for this reflector, which we accomplished on the day of August 1st, with returns coming satisfactorily back from it, that we were able to locate it now. And it now became a point of interest for most of the research that concluded the next 40 years. Here you see a scene of my team at Lick Observatory preparing the K1500 laser. I'll tell us a little bit about this laser. It had an output power of 1.5 gigawatts, the most powerful laser in the world. It had a pulse duration of 10 nanoseconds, or 10 billionths of a second. It was a pulse laser. We were able to get off 2 shots per minute with this particular device. It operated quite satisfactorily for the most part, but of course we did have some problems with it because it wasn't designed necessarily for this type of an application, but we were successful in adapting it to this condition. But we did finally receive information from the surface that we had located the reflector, and of course our job then at Lick Observatory was concluded, and we moved on to other things. However, this concluded the first ever interplanetary laser ranging experiment in history. So that's maybe our banner of recognition for this team of us that did this work. In the meantime, McDonald Observatory, which became the primary source for lunar ranging, took over this task. And for the past 40 years, they've been doing laser operations and technology related to Earth-Moon systems that I'm sure for those that are interested to know more about those Earth-Moon systems, that research has been based on the work done over these 40-some years at McDonald Observatory. And again, our objective here, you see on this slide at Lick Observatory, which was just to locate the reflector and then to identify its position for future use by other researchers. And I'll be at the Lick Observatory here in about another 10 days, where we celebrate the site as the first interplanetary laser ranging experiment in history, where we'll be working with IEEE and other NASA organizations to celebrate this particular site. I'm also a NASA JPL Solar System Ambassador. I've been one since 1991, and I'm proud to say it's been a great experience, and I'll recommend the Space Ambassadors Program to anyone that's listening that would love to be a part of things like this. It's been a very rewarding experience for myself and Betty. So that's all I have, and then we can ask some questions.
We do have a question that's from Michael Spinniken. Michael, thank you for being here, Michael. He's with the German chapter. And so that's another international chapter. It's great to have international participation, literally from 3 different international, because of course, the walkers represent Cape Town and South Africa. So that's wonderful. Anyway, Michael's question. When LRRs come finally to rest, when a final official data set will be established? Different numbers of coordinate data are unnecessary food for conspiracy theorists. I experienced during my CLLC initiative, that is coordination of lunar landing coordinates 20 years ago. Besides, the Smithsonian website still has the 2000 version. And what he's talking about is LRRR stands for, I'm not getting it. You know what he means by that, Al?
I think he's referring to the lunar laser ranging experiment.
Okay.
Yes.
So LRR of Apollo 11 now from latitude 0.67337 to 0.67345, longitude 23.47293 to 23.47307. For reflectors cannot walk around on a moon, but are the basic fixed points of a lunar coordinate system. And that's when he asked his question. When the LRRs come finally to rest? When will? I'm assuming he means when will they?
Well, I'm a little bit, excuse me, I'm a little bit puzzled by his suggestion. It sounds like he's thinking they're moving around, but whatever. There are 3 reflectors presently today on the moon. Apollo 14 and 15 carried the other 2, and 11 carried the initial reflector. These reflectors are still operational until this day. There's been some deterioration reported by the researchers who've been utilizing them recently. However, I'm not at all anymore involved with these reflectors and following them in any type of scientific way. But I think I just sort of keep, as we love to say, we keep our ears to the wall just to hear what some of the latest information is. Well, doing that, just recently, I think a few days ago, I read or saw information that a new device, a lunar reflector device, is being developed now, which will enhance the reflection characteristics of that particular device over this 244,000 miles, which of course will help to increase some of our knowledge of the true movement of the Earth and the Moon system. So I would hope that this gentleman could probably look into that and might get further information about what the future would be for lunar laser ranging.
What about tectonic plates in your experiment show?
Betty just reminded me of something very important to us here in California. We just recently, I'm sure as you all have heard or know about, had the 7.1 earthquake near Los Angeles. And of course, we were very hopeful that the researchers using the lunar reflectors would be able to continue to develop more accuracy of the continental plate drift here on the Earth, to start to work with some technologies involved with earthquake prediction methods. So we're looking forward to that, of course, with our interest here in this area and, of course, around the world.
Thank you, Hal. And by the way, other folks, I'm not getting any other questions. Oh, wait, there is another question. Now, by the way, Michael, if you want to ask a clarification question, please feel free to do so. And then Brian Dolenzal, can amateur astronomers prove we landed on the moon by laser reflection via the LLR as dramatized on the Big Bang Theory?
Well, that's quite interesting. I saw Claire chuckle. Oh, that's not Claire. Sorry, I thought it was Claire for a moment. But anyway, if she's listening in, that was a nice chuckle. Whoever you are, ma'am, how are you? But what will it?
You want to let them know Neil Armstrong?
Oh yeah, one of the things that Neil Armstrong. Well, but yeah, I got to think. I'm back to the question. One of the things I struggle with for just these many 50 years, and I'll make it a thought like that, is that people always said to me, Hal, why don't you tell the truth about this conspiracy thing that's going on? And I said, well, what is the truth that you're looking for? That Buzz Aldrin and Neil Armstrong never went to the moon. The U.S. never went to the moon. If anybody knows, you know, you were running the operation of those lunar reflectors. Are they really there? I said, well, I would have wasted my time doing that if they weren't. So what is it that you're trying to understand about asking me that question? I said, ask the guy that was on the moon. Ask Neil Armstrong. So over many years of sitting in AIAA conferences and other things like this where people gathered to talk about this, finally, Neil Armstrong, and I'm proud to say, came to the table and said, if anyone wants to know whether we went to the moon, look at the story of the laser reflectors. There's the evidence. So I'll just say that as a concluding point about that.
I put that laser up there.
That's a great story. Let's see. Any more questions? Let's see. There is another statement, Ed. So what is the minimum power and detection sensitivity to detect a reflection from LLR?
That's an excellent question. I had that question last night here in San Francisco. We have to first understand that the reflectors are an enhanced target. So therefore, if you have enough fluence on the target to give you back some reflection, you would get back some photons here on the surface of the Earth. However, depending upon the sensitivity of your detector, that would be the necessary specification about what the sensitivity levels to receive that. For example, I like to describe our system this way. We put out 100 billion photons from this laser at about 1 gigawatt of power and 10 joules of energy. That went to the moon in a spot diameter that was approximately 3 kilometers. We only got the reflected energy back from the reflector, which was only roughly a 24 square inch device. So see, we lost thousands of what we call millions of trillions of photons in the background. However, our receivers were sensitized enough that we could pick up 3 to 5 photons, and that was what we were successful in using. So unless you've got that type of ratio, you're probably not going to see very much.
Wow, great answer. Let's see, do we have any more questions? Oh, and good question from you. Ed is a member of our Sacramento L5 Society. By the way, we're very interested in things like lasers because we proposed excellent way. We actually did an analysis, a fairly thorough analysis of ways to power a lunar, either a lunar base or a lunar rover or a lunar device through the 2-week-long lunar night. And we proposed orbiting, or even at L1 or L2, placing a solar-powered laser that was using a highly collimated lens. And that lens would then be used to reduce the spot diameter on the moon of the laser beam. And we determined that we could actually do that. I'm sorry, you're probably not hearing me very well. And we determined that we could really use that to power through that 2-week period quite successfully and quite economically. And we have if you go to our sacl5.org website, you can find that analysis and other things that we did along that. This is kind of our interest. So I love that you're talking about lasers, and we need to talk. You and I in South Africa and the SACL5, we need to get together on these laser things, because we're talking the same thing. You know, we're going down the same pathway. A lot in common. We really do. So let's see. No more questions, and that's pretty darn good timing. It's 8:57, and that means we're very close to the end of our celebration, which means it's time to pop the old champagne.
Oh,
so here
wow.
I have the bottle of champagne. My wife has glasses on here on the label.
Who's sitting there with you?
Pardon me?
We wish we had a glass.
Have a virtual glass. So this is going to hit my ceiling. I know that. I'm not shaking it up. It's just going to explode. So this is our way of saying thank you, everybody who was involved in the Apollo mission. Thank you for the experiments. Thank you for the people that did all of the grunt work and made it work. Unbelievable. 50 years ago that we landed on the moon, that we were there, that it hasn't been done after Apollo to this day. And yet now we're going back. It's going to happen, and we owe it to those people that we're going back. So thank you, guys. And there goes the champagne.
Who's got champagne
glass
with you?
Come on, guys, take the glass.
Oh my God.
So we hope you're celebrating wherever you are.
Hey,
Joe,
Joe,
who is that with you celebrating?
hey, Joe,
Who's that with you?
Yeah.
can you hear me?
What's up?
Joe,
Yeah.
who is that with you?
Okay, I just want to point out something. 50 years ago today, the astronauts were resting or sleeping at this time.
I think I just woke them up.
But I just want to call other thing I want to point out. Do you realize what day of the week it was? You remember what day of the week it was?
Nope.
No.
Nope.
It was a Sunday. And I remember telling my family watching it on a color television, they're asking, why is every image black and white and gray? And then
So everybody come here.
that's when they all glazed over.
Everybody come here that's got a glass. Okay, Larry, we're all gonna click our glasses. And then if you're out there, if you have any beverages, click your glasses. Here you go, everybody. Everybody get in. You got one more you gotta click. Oh. There you go. There you go. All right. You want it all. Thank you. Thank you for joining us. And I loved it. I think it worked. It was a lot of work, but you know what? It was worth it. I have a tape, by the way, of this whole thing. So anybody wants to watch it again, let me know.
Okay.
And so that's it. And last words. Anybody, let's go down the list. Christine, you got anything to say? Christine nodding. Oh, she's muted.
Hello.
Oh, there she is.
Hey, thank you. This was wonderful. We enjoyed. We had, I don't know if we had 7 people here. Maybe
Okay,
6.
great.
Maybe 6.
Thank you, Christine. Phyllis, your reaction. Why don't you unmute for us? Oh, I just muted you.
There's 7 people. Okay, bye.
But oh, see you then? Okay, thank you, Hal.
Okay,
Bye.
you guys.
Bye-bye. Take care.
There you go, Phyllis.
See you in Cape Town at the International Space Conference.
2020.
Okay. Bye-bye, guys.